All right, so in the lesson today, 6.6, we're talking about general form of an equation for a linear relation. And what are the forms of a line that we've talked about up to this point? Slope, y-intercept, okay, slope y-intercept form. Now, just out of curiosity, do you remember what that is? Slope y-intercept, y equals mx plus b. Good. That is slope y-intercept form, or just slope-intercept form. What's another one? What's another form that we've talked about? Girls, pay attention. What's the other one? We had the song, remember? The song? What form was that? Yeah, what's that called? Point slope form. Okay? So this is point slope form. Yes, you can listen to the song, absolutely, after class. Perfect. You might want to do that. All right, so those are the two forms we've talked about already. We're going to talk about the general form now. So that's what 6.6 is all about. So we've found in our work in 6.4 and 6.5 that you can convert from one form to another. So we're going to still be able to do that. But the general form for the equation of a line, and I'm just going to give it to you here and then we'll talk about it. Okay, it looks like this. This is straight from your textbook, but I'm going to talk about what each of these things represent. Okay, so ax plus by equals, plus c equals 0. Actually, there's a yet another form, and that's where the equal sign is over here, so my bad. This is general form. Okay, now what do we notice about general form? What's one thing? What do you notice? As opposed to these forms over here, what do we notice? Anything? Sorry, nice nod. Okay, it equals 0, right. None of these equals 0. Okay? This one equals 0, and it always equals 0. If it is not equaling 0, if it equals 10 or negative 5, it's not in general form. It has to equal 0. Okay, very good. What's another thing you notice about this one? Anything else? If 0 is on one side, what's on the other side? Stuff that equals 0, yes, that's everything else. Okay, so the x term, the y term, and what would this c represent? Slope? No, not slope. What does c intercept? Maybe. Y? Okay, these are all good guesses. Generally, just if you have c here without a variable, that's a constant. Okay, so this right here is just a number with no variable. This is the x term. This is the y term. This is just a constant. Okay, so it's just a number. So we don't have a number on this side, we have 0 on this side. The number, if there is one, is over here on the left. Okay? Now, other things that you maybe have noticed, but you maybe didn't say, was that the x term is written before the y term. And that always is the case in the general form. You can't have those switched up. Okay? The x term comes first, then the y term, then the constant term. Now, the other thing is, a is a whole number. And if you look in your book on page 378, a must be a whole number. Okay, so that means that it can't be what? Okay, it can't be a decimal. That's true. What else can it not be? It can't be a decimal or a fraction. But what else can it be if it's a whole number? Do you remember what whole numbers are? What was that, Kevin? Sorry? Positive, okay. Whole numbers are, a 0 is part of the whole number set. It can be 0, yeah, cannot be irrational, but also cannot be negative, okay. So the whole number set is 0, then 1, then 2, 3, 4, 5, and all the way up as far as you can go. No decimals, no negatives. So it cannot be a decimal or a negative. And yes, with decimal there comes a fraction or an irrational number. Okay? So we'll just leave it at that. So A has to be a whole number, not negative and not a fraction. Okay? B and C are both integers. B and C are integers, which means that they can be negative or positive or 0, but what they can't be is fractions and decimals and stuff. Okay? So that's what integers are, and I think you probably know what integers are. All right, so there's a few things that we need to pay attention to if a line is in general form. Okay, so tell me if this is in general form or not. Are you ready? 3x minus 2y equals negative 5. Is that in general form or not? Okay, I see some heads nodding. I see some people saying no. This is not actually in general form because we have a number on the right side that's not 0. So how can I make this into general form? How can I convert this to general form? Yeah? Okay, you said something about putting the 5. You're on the right track. Okay, so what you exactly said was if we put negative 5 as the C and then put the 0 on the right side, you're very, very close. What we have to do is you have to bring that negative 5 over to the left side of the equation. Now, it doesn't stay as a negative. When we move it, it becomes positive. But, yeah, you're very close. So, in general form, we would do exactly that. We would add 5 to both sides to make this side equal 0. So we have this as general form. Understand that example there? Okay, so close to general form but not, and you can convert it. All right, so let's do another example. Okay, what about this? Negative 3y plus 2x minus 10 equals 0. Is that in general form? Well, let's take a check here. We've got equals 0. That's good. We've got an x term and a y term and a constant term. That's great. What's the one thing that's a little bit different that we would probably want to do? Okay, I'm very glad you said that, actually. I'm very glad you said that. It's not exactly correct, but I'm glad you said it because I wanted to make sure that I mentioned this, so thank you for reminding me. Now, it was mentioned that this can't be negative. This has to be positive. Well, the fact is that this, remember, this is actually the y term. So the y term can be negative. It's the x term that has to be positive. So, yeah, that's right. You saw the negative, but you didn't see the variable. So this is not technically in general form because we want to put the x term first. And how we do that is we simply rearrange these terms. So that's going to be 2x minus 3y minus 10 equals 0. Okay? So this is not general form, but there we go. And the x term actually is positive. So that's good. I'm glad you said that because you're right, it does have to be positive. Okay, here's another one. Is that good or no? In general form? Nope, not in general form. And why? Or why not? Okay, because there's a... Okay, you said because there's a decimal as a coefficient. And someone else over here said there's no y term. Okay? So, are those two good reasons why this is not in general form? Do you agree with that on both points? Alright, I agree with one of those statements, not the other one. Which one do you think I agree with? The fact that we don't have a y term, or that this is a decimal? Which one do you think I agree with? Okay, the decimal one, yes. Now, you're right. This cannot be a decimal here. That is absolutely true. We need to fix that. But the fact that we have no y term, okay, remember, a has to be a whole number. But b and c can be integers, right? Now, in both of these, A, B, or C could be what? Yeah, could be 0. So guess what? This actually is plus 0, y. If it doesn't show up, it means that there's a 0 coefficient. I know, it's kind of cheating, isn't it? So the fact that there's no y term doesn't mean it can't be in general form. It doesn't have to have a y term. But the decimal is, for sure, it has to be fixed. So how would we change this equation to put it in general form? Any ideas? Times 10. Okay, you could multiply it by 10 to get rid of the decimal, or you could also multiply it by 2 to make that a 1. So multiply by 10, that's totally fine. I'm going to do that. 5x plus, do I have to multiply this 2 by 10 as well? Yes, I do. 20, and 0 times 10 is still 0. So now this right here is better. If we were actually going to put it in general form, though, what should we include? You really should include the y term. So I'm going to ask you to do this, and I don't know if the textbook is going to do it or not, but just to show that we have all of the pieces to the general form. And like I say, I don't know if the textbook is going to require you to do this or not, but I am going to ask you to do this just so that you can see that, hey, that can be, that's an integer. 0 is okay. Hello. Yes. Okay, the question is, why did you multiply the 2 by 10? If you are trying to make this into another number and you have to multiply one of the terms to get a whole number, let's say in this case, it's an equation, okay? So what you have to do is you have to multiply the whole side by this number that you want, and because it's an equation, you have to multiply the other side by the same thing. And so you can't just change one term, you have to multiply all of the terms, okay? And it's a different equation if you just multiply parts of the... Yep. Yep. Yeah, that's right. I don't know if this will help, but if you think about 21, right, that equals 20 plus 1, right? So if I wanted to make this number 40, and I multiplied this by 2, and then multiplied this by 2, this would be 42 equals 40, and if I didn't multiply this one, that's what I'd have. And that doesn't make sense, does it? So that's why you have to do everything, every piece, by the same. Okay? So that's just a little example. All right. All right, what about this? Is this in general form? No, it's not in general form. What form is this? Slope, y-intercept form, yes. And which one is the slope? Where is the slope here? Negative 2/3, very good, is the slope. And what's the y-intercept? Positive 4. That's B, right? The y-intercept. Good. Okay, so I'm going to give you 20 seconds to change this to general form. See if you can do it. Okay? Make this into general form. Okay, so convert or just change to general form. Okay, go ahead and do that. Okay, so there's the solutions to both of those conversions there, okay, with a little bit of mess. So sorry I missed a few minutes of lecture there, but these are the answers for this question here. This is the question there, about all that stuff. Yep. So that's the point slope form and converting it to general form. All right. So this is the question we're dealing with here now, which says, here's the given linear equation in general form. It's in general form. And find x and y intercepts and graph the line. So we're going to finish off with this one. X and y intercepts. Okay. What we know about x and y intercepts are that they are coordinates on the x-axis is the x-intercept, and the point or the coordinate on the y-axis is the y-intercept. And these would be where the line travels through the axis, right? the coordinates for all y-intercepts would be 0, and then whatever this y value is, right? 0, y. The coordinates for all x-intercepts are x, comma, 0. So that is true for every intercept no matter what. And what you want to notice here is that for the y-intercept, x always equals 0, always. And for the x-intercept, y always equals 0. That's always the same. So when you're given an equation and you're asked to find the x-intercept, let's do that one first. What do you know about the x-intercept? Well, the x-intercept always has a y value of 0. So what you do is you set y equals 0. So let's just write this to find x-intercept. And I feel like I've written this out for you already before. Have I not done this before with you guys? To find x-intercept, let y equals 0 and solve for x. Alright, so that's how we're going to find the x-intercept. So let's do that real quick. Alright, so x is going to stay as x because we're going to solve for it, but y is going to become 0. Now when you have 2 times 0, that is 0. So this really becomes 3x minus 18 equals 0. I want to solve for x, so I get everything away from x, right? I want to get this all by itself, so I'm going to get rid of the negative 18, I'm going to get rid of this 3. So I'm going to add 18 to both sides first. 3x equals 18. And I'm going to get rid of this 3, so I'm going to divide by 3. And x equals what? 6. So the x-intercept is the point 6, 0. 6 is the x value, and we let y equals 0, right? So there's x equals 6 there. And for the y-intercept, I actually don't know if this is what it looks like here yet, but let's find out. So if you're a note-writing person and you want to write the other side of it too, let x equals 0 and solve for y to find y-intercept. So if you're finding y, let x equal 0. Always the opposite one. If you're finding x-intercept, let y equal 0. And then that looks like this. 3 times 0 now. Plus 2y. Minus 18. And as we quickly finish that off, we solve for y equals 9, so the y-intercept is the point 0, 9. And this is not to scale, but 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, and that's sort of what the line looks like. Okay. Now, I drew the graph first. I shouldn't have, but let's just say this is you doing it, and you find intercepts first, because you're not going to know what the graph looks like. So you find the intercepts, and now to graph is easy. Okay, this is how you do it. You just draw your x and y. Okay, 2, 4, 6, 8, 10. So we have 0, 9 is one point that we know of for sure, and then 2, 4, 6, 8. So 6, 0 is our other point, and voila! You connect the 2 points with a nice straight line, unlike mine, and there's your line. There's your graph. Okay? So you simply plot the x-intercept and the y-intercept, connect them, you're done. All right, one more example, then I'm going to give you your homework, which we'll have 15 minutes to do in class. You're welcome. This example says, determine the slope of this equation. So 3x minus 2y minus 16 equals 0. determine the slope. All right. Now, if you do enough of these, you may come up with a little bit of a pattern, and you might be able to do this either in your head, or you might be able to find a shortcut. Okay? I'm not going to show you any shortcuts here right now, but what I want you to do is to see if you can kind of gather, some information as you do more and more of these. But if you want to find the slope of a line, it would really be handy if it was in slope, y-intercept form, right? So if it's in that form, you can see the slope really easily. So that's what I would suggest that all of you should do, is change it to point slope form. That's the method that they're teaching you. Now you may be able to, after some practice, be able to look at this right here and be able to see the slope. Okay? But it'll take some practice. And you could get it wrong if you do it all in your head. So I would suggest taking just a few minutes, and I'm going to do this rather quickly now, and show you how to get the slope. Okay? So let's isolate y. Okay, so I'm going to do negative 2y over here, and I'm going to get the 3x to the other side, which is going to make it a negative 3x, and the 16 over there to make it a positive 16. All right? Sorry? Whoa, okay, whoa, what? Do we have a train wreck here? Okay, you don't see what I did? I just got those other two terms out of the way, off to the other side. Okay, I didn't touch the negative 2y, I didn't touch it. I left it there. Okay? Was that too much at once? Some say yes, some say no. Okay, you can do this individually if you want, right? Take the 3x to the other side, make it a negative 3x over there. The 16 goes to the other side, becomes a positive 16. Now I'm going to divide by negative 2. And I'm going to come up with here, y equals 3 over 2x minus 8. This is now in slope-intercept form. And what is the slope? Yeah. Slope is 3 over 2. Okay? So if you're given an equation in general form, and you're asked for the slope, the best way is to change that form into slope-intercept form, and then you can see the intercept. Okay? Any questions? Okay, then I'll give you an assignment to work on, and we'll go from there. Just a note, standard form, you need to know what standard form is here. Um, it's very similar to general form, except the constant is on the right side.